Here we have the rational function s of x equals 8 minus 7x divided by x plus 5. We're asked to find the intercepts, asymptotes, domain, range, and graph of the function. First of all, let's look for the y-intercept. And to find the y-intercept, we will be evaluating s at 0, substituting 0 for x. This is going to give us 8/5. And so the y-intercept is 0,8/5. Now the vertical scale is counting by 4. This is between 1 and 2. I'm not going to be able to depict it very accurately, but let me just put it there. The x-intercept requires that we solve s of x equals 0. And we remember that if the rational expression is equal to 0, its numerator would have to be 0. So 8 minus 7x would equal 0, which would say that 8 would have to equal 7x, or in turn, that x equals 8/7. So the x-intercept is going to be 8/7, 0. Again, 8/7 is very close to 1, or is between 1 and 2, and so we'll put it in here. The scale on the horizontal axis is counting by 2. Okay, now the vertical asymptote. Here we have a vertical line that occurs at the 0 of the denominator. So x plus 5 equals 0 if and only if x equals -5. So the vertical line will have the equation x equals -5. So we're counting by 2's here, and so -5 on the horizontal axis would be about here. It's the vertical asymptote. The horizontal asymptote is found by first looking at the degrees of the numerator and the denominator. This time the degrees are the same. I can rewrite it as -7x plus 8 over x plus 5, 1x plus 5. So the y would equal the leading coefficient of the numerator, which is -7, divided by 1, which is the leading coefficient of the denominator. So y equals -7. And so the horizontal asymptote is going to be occurring at y equals -7. We're counting by 4 on the vertical axis. So I believe -7 would come through like this. Now notice that the asymptotes also are restricting the domain and the range. The domain will include all x values except for -5. And the range will include all y values except for -7. So we know that our function is going to go through both of the intercepts and approach the vertical asymptote as we move to the left and the horizontal asymptote as we move to the right. But this is only one branch of the hyperbola. Here, this shape is called a hyperbola. And the other part of the curve is going to be symmetric with respect to where the two asymptotes cross. And so in this case, that's -5, -7. Now, we've got some fractions here in terms of the x and y intercepts. But let's notice that the x-intercept is at 8/7. The vertical asymptote was at x equals -5. And so the distance between those two is approximately 6. So if I go 6 units to the left of the vertical asymptote, I should get something pretty close to the same distance from the horizontal asymptote that we found the intercept at. So let's look at S of, I'm going to go 6 units to the left of that asymptote because the intercept was 6 units to the right, more or less. So when I go do S of -11, that's 6 units smaller than -5, I get -7 times -11 is 77 plus 8 all over -11 plus 5, which gives me 85 divided by -6, and this gives me -14 and 1/6. So notice that whereas the x-intercept was 7 units above the horizontal asymptote, this value of S of -11 is going to be 7 units below. And so we're counting there. This is 4, 8, 12, and I've got to go a little bit further down there. And this is 6, 8, 10, 11. So we'll be about over here and there. Now the reason I did that was because if we're able to properly draw this, the graph is going to appear to be symmetric with respect to -5, -8, which is where the two asymptotes crossed. So this would be the point -11, -14, and a sixth. And I think the graph does appear to be roughly symmetric with respect to that point. So the graph occurs in the top right and the bottom left section of the quadrants created by the asymptotes. And this is characteristic of a rational function which has a linear function on both the top and the bottom. These are all going to be hyperbolas that show this symmetry around the point of intersection of the two asymptotes.